Hello, today we're discussing how to rotate a matrix by 270 degrees. So to start, let's look at the various ways that we can get to 270 degrees. So I'm going to draw my axes here. This is horizontal, this is vertical, and this is where 0 is. So one option, the first option, is to do exactly what they want us to do and rotate to 270. When we do, that brings us to right here. Another approach that we can do is to rotate by 90 degrees once, rotate again by 90 degrees a second time, and then rotate by 90 degrees a third time. And if we do 3 rotations of 90 degrees, that will also get us to 270 as well. And then there is a third approach to get to 270. The third approach is to rotate backwards by 90 degrees. So we go negative 90 degrees, and that will get us to 270. So as you see, we have 3 different ways of getting to 270. In terms of coding, it's actually convenient for us to express things in terms of 90 degrees because we can use that same function for other problems. So now that we've committed to doing this problem by rotating in 90-degree increments, what we're going to do is we're going to take our given input and then rotate this by 90 degrees. And then after we've done that, we're going to look at various methods that we can use on that particular problem. So let's rotate A. Imagine that A was on a sheet of paper like this, and then you take that paper and then you turn it sideways like this. If you do that, you're going to end up with your rotation by 90 degrees. So what does that look like? If we did that, we would have this. Let's call this A underscore 90 or just A90. And this represents taking this and rotating. If we did that, the 4 would end up at the top. So it would be the top left. So we'd have 4 and 1. Then we would have 5 and 2 and 6 and 3. So this represents the rotation of A by 90 degrees. So in the first approach, we're going to determine the rotation of A by 90 degrees by using the transpose. And to define what the transpose is where you simply swap out the columns and rows. So this is our matrix A. We got the rows here. This is one row. And then we got 4, 5, 6 as the second row. The transpose, again, is just simply where you swap them out. So let's find the transpose of A. We're going to call that AT. So the transpose of A, we're going to get 1, 4. That's going to be the first row. Then we're going to get 2, 5. That's going to be the second row. And then we got 3, 6 as the third row. And this represents the transpose of A. Now, there's actually a relationship between our transpose and the answer. And to see that relationship, you can just compare each one of these rows. Let's look at the answer. The first row, we got 4, 1. Here we got 1, 4. Looks like it's the reverse. Let's see if this is true for all the rows. For the second row, we got 5, 2. For this one, we got 2, 5. For the third row, we got 6, 3 in the answer. And then in the transpose, we got 3, 6. So it appears that in order to get the transpose to be the answer, all you need to do is simply loop through each one of your rows and then reverse them. And that's exactly what you got to do in the code. So to find the rotation using the transpose, we're going to go through each one, and that will give us, reverse this, you're going to get 4, 1. Reverse this row, you get 5, 2. Reverse this row, you get 6, 3. So, as you see, by using the transpose, you can actually obtain the rotation of A by 90 degrees. In the second approach, we're going to determine a relationship between the elements in the rotated array and those same elements in the original array. Once we have that relationship, we can then use it to determine the answer for rotating 90 degrees. In order to define that relationship, we have to first define some variables. So we're going to define J, which represents the row index in the rotated array. So J is going to be equal to the row index in the rotated array. And then also in a similar fashion, we have I, which represents the column index in the rotated array. So I is going to be the column index in rotated array. Another variable that's very beneficial to define is going to be R. R is going to represent the row count in our original matrix or array. So R is going to be the row count, so the number of rows in our original array. So row count of A. And then also in a similar fashion, we have C, which represents the column count of A. Another variable that is very beneficial to define is RJ. RJ is something that's arbitrary. I made it up. You can call it Z, you can call it X. I call it RJ. And what RJ means, which is the most important thing, what it means, it represents the largest possible row index. So it is related to R. So RJ is going to be equal to R minus 1. So once we have all of these variables defined, we can then write a relationship which links the rotation with the original. When we do that, we get this. So we'll have A rotated by 90 degrees. If we're looking at the jth row and then the ith column in that, that's going to be equivalent to the original array at RJ minus I, and this is again going to be the row that you're looking at, and then we're looking at the jth column. So again, this is our magical relationship that we can use to link the rotation element to the element in the original. And then in order to get your rotation by 270 degrees, all you need to do is to use this relationship here and then apply it 3 different times to obtain a 270 rotation.